Let us just wait for them to settle down. Ano yan? Oh, sige, kasya pa yan. Pagka may dumating po naman. Medyo mainit. Sabi mo, mainit na sa labas. Okay, nakatakot ko ba kayo ba naligaw sa baba? May kasabay kasi kami meet up sa baba. Kung doon kayo dumaan sa front na stairs, matandaan nyo yung space ng Google. They have their own meet up there. So, they're inviting me to go there. Kasi yung meet up din kami. Sino yung mga first time nakapunta dito? Oo! Huwag pa sila daw sa dito. Kasama. So, wait for them. Sino naligaw? Wala naman.
Ako, sir.
Si Kenneth. Except that, pag weekends, kasi usually they don't turn on the elevator. Pero I was hoping that they will turn it on kasi may event din sa baba. That the space downstairs is owned by the guys who own this entire space. So, tenant kami ng Pallet Express. So, Pallet Express is a co-working space. They are based in Spain. This is their branch in Manila. We are one of the first tenants of Pallet Express here in the Philippines. So, kami may sarili kami space. Before, kung nakapunta na kayo dito, this place, this entire floor is not this kind of office space. So this is one big co-working space. Kami Mozilla, when we started here, March of 2014, isang lamesa lang kami. Yung spot na yun, sa may bintana, yan na yung spot namin. Yan lang dati yung Mozilla Philippines. Then we had our own space now. That's why, meron kami mag-event ng sarili namin. Tapos kumain na rin yung mga kapitbahay namin. Nagpalagay na sila ng wall, so kanya-kanya mag-isip. Okay? Just wait for one more. Okay, cool. So if you like to get water, coffee, that's all that we can offer, and Wi-Fi. Okay, so it's there. Just feel free to get it from there. The restrooms are located at the back of this wall. So paglabas nyo dyan, dito sa left side. Ladies and men's room are here. Okay? So here, so we start. So magandang hapon sa inyo lahat. Maraming salamat for being here at the Mozilla Community Space. So this is the second run of our introduction to Rust programming language. Okay? So before we start, so if you're on social media, we're using the hashtags MozillaPH and RustPH. Okay? We are recording the session for our friends who are unable to go here and for our friends abroad. And we'll just upload it at our YouTube channel later this week. If you are on Foursquare, Mozilla Community Space is there at Foursquare. So just search for it and then log in. Okay. What else? So let's get to know each other first. So I want this session to be an informal kind of thing. This is not a seminar, okay, though you'll learn stuff. Okay? So just tell us what is your name, from where you are, and what do you do. So I'll start. My name is Bob Reyes. I'm one of the Mozilla reps here in the Philippines. I'm from Makati. What do I do? If I'm not with Mozilla, I have my own business. So we do web services, IT services, and consultancy. Okay, so let's start with you. Okay. Pagano na lang. Just tell us what's your name, from where are you, if you're a student, where are you studying, and what's your course. And that's it. Okay? Para at least medyo magkakakilala tayo. Yeah.
My name is Robert Seymour.
Robert. Hi.
From SPNS. Summer student.
Saan school?
UPHS.
Las Piñas. Okay, cool. University of Perpetual Health System Data. Okay. UPHS. Okay, cool. Jared. Robert, Jared.
I just got my college in
Las Piñas. Okay, cool. Yes, sir.
I'm Mike Kalumbi. I'm from Subat, Paranaque, and I work as a job
For which companies? Uni.
Uling.
Ulink. Okay, do you logistics? Okay. Okay, cool. Salamat, sir.
I'm Mark Andres Vanessa. And magkakasa kami
From UP is cool.
sa we're just graduated this last week.
Anong course niyo na pala? Computer science? IT. Cool. Magkakaklase kayo, magkaka-schoolmate kayo. Okay, cool. Yes, sir.
My name is Mark Roca. I'm working as a IT
Yeah. HPE. Okay. Okay, cool. Yeah, from UP.
Student from Manila. Studying at University of This.
Okay, hi. Sige, si ma'am, karating lang. Hi. Just have to tell us your name, from where are you, and what you do. Sakto, kaya kanya pinaupo dyan. Actually, pinagkaisa kayo yan.
I'm currently Mabilana. I'm studying PSIT in PW.
Oh, hi. Next, sir.
Hi, good afternoon. I'm Eugene Marbella from Philippine University also. So, sama lang kami. Then, PSIT.
IT. Hi.
Hi, I'm Fatima Music for Quezon City. Taga-Vidas.
Cool.
I am doing Salazar from PW.
Hi.
I'm Eliza Ramos from University. I'm studying at Philippines University PSI.
Okay, cool.
I'm Chef Isla. A.K.A. Margaret Kamal. My course is PSIT and I school at
Hi. Kumusta? Okay. So back, sige, ladies first. Okay.
I'm Denden po. From Makati, I work as a trade engineer in Summit Media, pero I transferred in Aeroscience
Okay.
last
Hi.
I'm Kevin from Makati, working as a digital.
Okay, cool. This guy is, sige, siya muna. May bisita tayo, import.
I'm Kenneth Hayes Kaya from Kabuyao, Laguna. I'm a web developer.
Import yan from United Arab Emirates. Okay. This guy is,
Hi, I'm Kim. I'm from Laguna as well. I'm day job. In Mozilla, I usually handle the page.
siya ang
I'm the
aming
only one.
de facto photographer.
Yeah. The one who's usually handle the photos.
So if you will see our Flickr feed, so in Flickr we are Mozilla PH. Mozilla PH MozPH, MozPH. MozPH, okay? So, most of the time, yung mukha ni Kim hindi nyo makikita kasi most of the pictures there, siya kumuha. Okay, so these are de facto photographer. He's also a Mozilla rep. Here in the Philippines, we are 10 Mozilla reps. Okay? So, representing schools ngayon, we have University of Perpetual Health System Delta, UE, PWU, sino pa ba? Letran. Okay, Letran. Adamson, think they're coming. Okay. Or they are not. Okay. So, I had around almost 50 RSVPs for this event today. So, yeah, so we are more than half of that. Now, saan nyo nalaman yung event about us? Meetup, Eventbrite, Facebook. Sino ka lang sa Facebook? Sir, sinabi lang sa akin ng kaibigan ko. Okay. Kayo, paano nyo nalaman? What you perpetual? Eventbrite. Okay, cool. We're trying to experiment different ways on how we are going to let people know about our events. We are still surprised that some people didn't know na meron kami community space. So parang sometimes when they are here, parang, oh, meron ka ng office of Mozilla sa Philippines. Actually, this is not an office, this is a community space. So I'll explain what that is all about later. We go first. What is Mozilla? If you're first time here, okay, so you see it's Mozilla. And most of the time when we ask people, ano Mozilla? Ang sagot is, tama, browser. It's more than a browser, okay? I'm going to show you a very short video clip. It will tell you the history and what the summary of what Mozilla is. Okay, so here it goes.
In the beginning, the web was simple, connected, open, safe. Designed as a force for good, it would become something far greater. A living, breathing ecosystem in service of humanity, a public resource for innovation and opportunity. Place to build your dreams. But in those early days, like any ecosystem, the web needed nurture. As it grew, users faced new challenges, pop-ups, viruses, a lack of choice, walled gardens of content. The web was frayed, it was slow, complicated, scary. Users began to ask, is this it? Or could the web be something better? A small group of people, coders, designers, idealists, believed it could. They had an audacious idea that a tiny nonprofit and a global community could build something better and force new ideas and innovation onto the web. They called it the Mozilla Project. They began by making a new kind of web browser, what we know today as Firefox, and they made it a nonprofit so it would always put the people who use the web first. More than software, it was a platform that anyone could use to build on their ideas. The nuisances diminished. The foundations of the web we know today began to appear. Now, the web is a place where you can build almost anything you imagine. Mozilla and Firefox exist to help people everywhere seize this opportunity and to stand up for users in a world where choice and control are too often at risk. But what if Firefox was just the beginning? What if it was part of something bigger? From user privacy to Firefox Mobile to apps and identity, we're pushing the boundaries of the web every day. And we're going beyond software. We're helping to build a generation of web makers. We believe the web is a place where anyone can come to build their dreams. It's why we make Firefox. It's why tens of thousands of volunteers help build our products. It's why hundreds of millions around the world use our software. But most importantly, it's why we always put you first and stand up to those who don't. Millions know us for Mozilla Firefox, but we're about so much more. We're a non-profit fighting to protect the web we all love. Join us. We need your support. Make a donation today.
Okay, so based on the video, okay, so Mozilla is a non-profit. So we are a global non-profit. And most of the time when we tell people that we are a non-profit, we ba tumataas yung kilay. Parang, oh, non-profit pala kayo. So most people thought that we are as big as Microsoft, Apple, Google. Okay? were in fact hindi. So sabi ko nga, pag pumunta kayo sa headquarters namin sa Mountain View, kapitbahay namin doon si Apple, si Google, Microsoft, we do not have a campus there. But Mountain View is called the Silicon Valley. So lahat ng malalaking companies, when it comes to tech, they are there. Ang Mozilla headquarters namin is just a 2-story building. And that's it. Okay? When most companies there, they have their own campuses. Bakit campuses? For example, Google, I know they have around 15 buildings within their campus. So, ganun kalalaki yung opisina nila. Kami, being a non-profit, we started with this. Netscape. Okay? So, several years ago, iba siguro hindi pa pinapanganak, pag pinanganak na kayo, pero hindi pa kayo gumagamit ng computer, that's where Mozilla started. Okay? So, that was during the era when sa internet at tinatawag is yung browser wars. So there was a war happening between Internet Explorer and Netscape. Why? During that time, it was early 1990s up to the late 90s, Microsoft Internet Explorer owns 98% of browser market share worldwide. Okay? So almost wala silang kalaban. It's like a monopoly. Okay? So kung matatandaan nyo sa video, meron doon kanina, may pop-up na yung option niya is yes and yes. So it's like, ganun yung option mo. You don't have a choice but to use this browser. So nagkaroon ng isang startup, Netscape Communications, gumawa sila ng browser, yun yung lumaban sa Internet Explorer. Ang unang premise doon is, hindi dapat monopolize yung browser market scene sa buong mundo. Now, came the time wherein Netscape folded. Netscape is a business. It's a startup. So kailangan niya maging profitable. Hindi na siya profitable, and it was going to be acquired by AOL, America Online. Okay? Then our engineers at Netscape thought na if America Online will buy Netscape, nakikita mo na kung ano magiging end mo. Mapatay nila ang Netscape. Okay? Why? Siyempre, may mga allegiances yan. And America Online is known to be siding dun sa kalaban. Okay? So, binili nila yung kalaban, kami Netscape. Our engineers would not want for the project to die. So, they thought, ipamigay natin yung source code ng Netscape sa buong mundo ng libre. Okay? During that time, hindi uso yun. Okay? The only known open source project that time was Linux, yung operating system. Kung ikaw gumagawa ng software, you will not give away your source code to anyone. Bakit? Para kang chef. Pag gumawa ka ng pagkain, hindi mo pamimigay basta-basta yung recipe. It's your signature style. It's your recipe. Pag pinamigay mo yung recipe mo, you're dead. Okay? And ayaw mangyari ng mga engineers namin na mamatay yung software. So, naisip nila, pamigay natin yung source code. And it was called the Mozilla Project. That was in Feb 1998. Okay? So, siguro mga bata pa yung iba. Ako, that time, college. Yung iba, yeah, sa mga bata pa yung iba. Pinangalan mo, pero bata ka pa. Okay? So, second most asked question sa akin, personally is, Sir, bakit Mozilla yung pangalan ng project? You know, engineers, they have weird ways of taking things. Okay? So, they want a mosaic killer. Okay? It's a browser engine. And, according to one of our engineers, na nakausap ko, sabi niya, wala na silang maisip na itong pangalan. Eh, palabas na yung Godzilla that time sa Amerika. So, they thought of, Mosaic Killer plus Godzilla is Mozilla. Kaya, ang aming mascot is a dinosaur. Okay? Yun yung relevance nun. So, the Mozilla project was launched March 31, 1998. So, yeah. Since we are a non-profit, we have a manifesto. We have a mission. Okay? So, we live by our manifesto. What is our manifesto? It is to ensure the internet as a global public resource, open and accessible to all. When we create products, this is what is on top of our minds. It must be for the public benefit. It is for the promotion of an open and accessible web. Okay? And for us to realize this mission, we need products. And our best known product is Firefox. Pero hindi lang Firefox ang aming products. Marami kaming products. At lahat ng products namin ay libre. Okay? That's the spirit of having an open source organization. Okay, now, since we are an open source organization, we are a non-profit, joining Mozilla is open to everyone. Okay? You don't need to pay anything. You don't need to specialize on so much tech stuff. Kahit sino pwedeng sumali. What are the different ways to get involved to Mozilla? I normally introduce getting involved to Mozilla this way. Okay? Sino gusto ng Mozilla shirt? Firefox shirt. Okay? Iba ayaw, okay lang. Wala akong t-shirt ngayon. Okay? But most of the time, when we go places, at tinatanong guys, sir, pay naman kami yung t-shirt. Okay? Remember, one, we are a non-profit. Two, we are not an apparel company. Okay? So, the shirts, this is an official shirt. This is for the team. Walang naka-Firefox shirt eh. Pero minsan, may makikita kayo yung may Firefox na logo, na shirt. Hindi dito ginawa yun. So all of our shirts, all of our swags, giveaways, including the stickers, they are all the way from the States. So pinapadala sila rito. For you to get, let's say, a Mozilla shirt, a Firefox shirt, it's either you win in a raffle or you donate to Mozilla. Okay? If you will donate to Mozilla for, I think, $30, there's an option for you para padalang ka ni Mozilla ng t-shirt as our way of saying thank you. So ganun kamahal yung t-shirt na yun. It's almost $30. But, may catch yon. Since the shirt is coming from the States, pagdating dito, bahala sa tax. Hindi namin sagot yun. Okay? Mura lang naman yung tax. The last time that I paid a tax for a shirt, it costed me something like 1,000 pesos per shirt. Yes. Ganun kamahal ang tax sa apparel ng Philippine Bureau of Customs. Okay? Hindi kami nag-implement doon, customs. Kaya pag pinadala ka ng kaibigan mo or ng kamag-anak mo from the States or somewhere, going to the Philippines, tapos pumatak sa post office, there's a customs officer there, bubuksan yung package, nakita, uy, this is an apparel. May tax yun. Okay? Ganun kamahal ang tax sa Pilipinas. Okay? Hindi kami, kaya yun, we basically will not pay for the tax. It's at your own risk. So dito sa Pilipinas, sometimes when Mozilla sends us package, minsan pinagsasabay-sabay na nila and they put explicitly on the box, no commercial value, these are donated items para walang tax. Pero pagka kayo pinadala kayo or bumili kayo online, especially from the States, prepare your money for tax. Okay? So the best way for you to get Mozilla Swags right now is to join Firefox Friends. Okay? Sino nakarinig na niyan? Kasi karamihan, first time here. Alam mo yung Firefox Friends? Sino walang Facebook? Okay, cool. Okay. Meron akong kaibigan, wala siyang Facebook. Pero meron siyang Twitter. Sinong walang Twitter? Okay, cool. Sinong walang Instagram? Okay, pero at least may Facebook. Diba? Bakit? For you to join Firefox Friends, you need any of those social media channels. Why? So that's the site, friends.mozilla.org. You log in, you sign up to the site using your social media account. You connect your social media account to our website and then start sharing posts pre-built into the website. So these are posts related to Mozilla, our campaigns and products. Every time that you post using the website to your social media channels, you earn a point. Saan pwede gamitin yung point na yun? Yung point na yun, pwede mo ipagpalit later on ng Mozilla Swags, t-shirts, caps, etc. Okay? Kung gusto mo, notebook, Moleskine, notebook, we have that, Moleskine. Okay, cool. Yo, so mga ganon. So this is the best way for you to get a Mozilla Swag or a Firefox Swag. Kung ayaw mong sumali sa raffle, kasi we normally raffle up items pag pumunta kami sa mga schools, pag may mga events, except that yung mga ganitong event, hindi kami paparaffle. Kasi pero pagka big events, meron kami mga raffle items and door prizes. Okay? So that's one. Second, sino yung, babalik tayo yung tanong, sino yung hindi student? Yung hindi na student. Okay. Kasi karamihan students. Okay? For students, we have this program. It's called the Firefox Student Ambassadors. Sino yung mga FSA? Meron ba? Bodo sa dalawang yun. Dati silang FSA. Wala. Okay. We have this program. Okay, this is a global program. It's called the Firefox Student Ambassadors Program, FSA. Ano ang ginagawa ng mga FSA? They represent Mozilla in their campuses. And in turn, your campuses gets represented to the global organization of Mozilla. Bakit? You are able to attend global meetings. You will be trained by Mozilla locally and abroad to different products and to different aspects of our organization. Okay? Ano pa? Marami pang perks yan. If you want to create your own Firefox Club in your campus, we can support you with that. Okay? Sir, ano ang requirement para sumali sa FSA? Tatlo lang. One, you must be at least 18 years of age. Okay? Sir, 17 na ako eh. Oh, let's wait until you get 18. Kasi it's a global requirement. They said that it's the average legal age for all countries. Okay, so 18 at least. Second, you must be enrolled in any learning institution. Bakit? Kung hindi ka enrolled, hindi ka student, hindi ka pwede maging student ambassador. So, yung second requirement. So, 18 and enrolled. Third, you must believe and be passionate of what Mozilla is doing. You cannot be an ambassador of anything if you do not believe in that product or that organization. Okay? So, yun ang requirements namin. If you have those qualifications, just go to that site and sign up. Walang limit kung ilan ang FSA per campus. That's how unique our program is. With other organizations, they try to limit that, hey, per campus, 3 or 5 lang ang ambassadors namin dyan. Sa amin sa Mozilla, wala. Kung gusto nyo, buong klase nyo mag-sign up, pwede. Tapos you will be trained. May mga levels yan. You'll get some perks and so on. Also, you get a chance to be invited to Mozilla global events. Okay, so I think the last time that we brought people was January. Tama Kim, no? January tayo puntang Singapore.
Yep.
January this year. Dalawang student ambassadors naman namin sa Singapore. Okay? 3 years ago, nagsama kami ng dalawa rin na student ambassadors from different schools. Actually, maraming invited doon, pero dalawa lang yung nabigyan ng visa. Sinama namin sila sa headquarters namin sa Silicon Valley. Okay? All expenses paid for, Mozilla. Okay? Pati visa. Siyempre, approval ng visa, hindi namin sagot yun. Pero pag in-approve yung visa doon, sama namin kayo. Okay? So, yung ibang perks. Aside from yun nga, you get to know the technologies na i-launch ng Mozilla firsthand. You will be trained here and abroad. Okay? Depende sa availability. Pwede rin online learning, okay? Trained by people who works at Mozilla, who creates the technology, that awesome stuff, okay? So, para sumali, just go to that site, or later on, yeah, kung may tanong kayo, just approach us, we'll just be here. Ano pang meron sa Mozilla? We have this internship program at Mozilla, okay? Take note, internship is not equivalent to OJT. Okay? Kasi common misconception sa Pilipinas is OJT. Internship is different. Okay? So, kung napanood nyo yung pelikulang The Internship, yun sa Google yun. It's similar to this. Okay? You get the chance to be an intern to any of our offices globally. Okay? Japan, Toronto, London, Mountain View, San Francisco, Auckland, New Zealand, Paris. You get to choose saan mo gusto mag-intern. You have to apply, though. Okay? So, kailangan mo mag-apply dyan. Siyempre, may exam, may interview. Hindi kailangan techie. Bakit? Meron kami mga positions on marketing, on creatives, okay? Community building. So, not necessarily techie. Kung techie ka, gusto mo sa engineering, pwede. Apply ka as an engineering intern. Sa department sa Mozilla, marami. Meron dyan coding on Firefox, merong add-ons, merong rendering. Okay? Yung head ng rendering department ng Mozilla, Pinoy. Graduate siya ng Ateneo, pero doon siya nakabase sa San Francisco office namin. Okay? Sa Paris, wala na eh, pero yung dating community manager global, half Pinoy siya, mami niya is Pinay. So, lagi siya sa Pilipinas. Sa Toronto, meron dyan mga engineers. They're Canadian, pero magagaling sila mag-Tagalog. Okay? Mga cool yung mga tao na. Sa Canada, kung sanay sila sa English, yung second language na pinag-aaralan nila, Tagalog. So, maraming marunong mag-Tagalog dyan. Okay? Yeah. So, paano mag-apply? Just go to careers.mozilla.org, then select internship. Okay? It's ongoing. Ang ano lang dyan is, pag tinanggap ka namin as intern, prepare yourself to be abroad for 6 months. Ang internship is 6 months. Okay? So, paalam ka na sa school mo. Or, sir, pwede ba dyan kahit graduate na ako? Pwede rin. Okay? May certain requirement lang yung different departments kung anong, ilang taon yung requirement nila. Okay? Global yan. Global. So, sa Pilipinas, marami nakapasa pero wala nagtutuloy. And this year, ako, tuloy ba yung dalawa? Hindi pa. Okay, hindi pa ituloy.
Mahirap daw.
Mahirap. Depende kasi sa position na ina-apply mo. Okay? Cool.
Kailangan may experience.
No, not necessarily. Not necessarily. Not necessarily. Okay? So parang ganito, clue or tip. I mentioned na yung head ng rendering department namin, Pinoy yung manager. He has 30 engineers below. Okay? So bossing siya doon sa amin. Ang requirement niya lang, magaling ka sa math.
Ay, ako na.
Doon sa department niya, siya mismo hindi siya engineering graduate, hindi siya IT graduate, pero math major. So, yun ang requirement niya. So, pagka in-interview ka niya, prepare yourself na magaling ka sa math. So, every time that I will see him, he asks me, Bob, nasan yung mga interns namin from the Philippines? Sabi ko, sir, alam mo naman sa Pilipinas, ang alam lang ng mga tao ng OJT. Ayaw nila ng internship. Kasi may mga gano'n, may mga students na before nag-apply, nakapasa sila, ayaw pumayag ng school na mawawala ka ng 6 months. Okay? So, depende yun sa schools nyo. Or, kung gusto mo, graduate mo, nasa-apply ka ng internship. Pwede mo. Okay? Pero we'll take care of everything. We'll take care of your airfare, visa, accommodation, and you'll get stipend. But the best thing there is, you will learn a lot. You will learn a lot. Okay? Alam niyo yung JavaScript? Yung isa sa founders ng Mozilla, siya yung nag-invento ng JavaScript, si Brendan Ike. Okay, so before, may mga interns kami on JavaScript, si Brendan Ike mismo tuturo sa kanila. That's how cool it is. Okay? Later, yung Rust, I'll explain why Rust is relevant to Mozilla. Okay, so now, what are the other cool stuff that we are doing at Mozilla? Sino yung mga mahilig sa games? So, mahilig lang manood ng mga naglalaro. Okay? Right now, when we play games, it's either you buy the software, install it to your machine, or Steam-based. Okay? Yeah, ganun. So, ito yung ginagawa namin with, alam niyo yung Unity? Narinig niyo yung Unity? Hi! Palag na lang next. Ayan. Palag na lang doon sa logbook. Thank you. Okay? So, alam niyo yung Unity? Narinig niyo yung Unity? Alam niyo yung Unity? Hindi. Okay? So, if you want to create cool games, awesome games, there's a software called Unity. It's like a programming interface. Okay, so this is what we're doing with them. Those games are being played in a browser. Full screen lang. So it's done using Unity 5. Anong language? ASM.js. So that's one. So cool things are happening in games. We started with this a few months ago, MozVR. So we're bringing the power of virtual reality to the browser. Okay, so you don't need to install anything. Sa browser pa lang, can view VR-enabled websites. Sir, kailangan ko ba ng Oculus? Not necessarily, kahit Google Cardboard pwede. So install mo lang yung Firefox sa smartphone mo. Then go to a VR-enabled website. Pwede mo siya makikita. Okay, ay, palag na lang doon sa library. Salamat. Now, going to the last of my slides before we go to Rust. Okay, so how to be part of Mozilla PH? As mentioned, you don't have to be techie. We have different areas of contributions. Support, testing and QA, coding, marketing, translation and localization, web development, marketplace, add-ons, visual design, documentation, writing, and education. you will see almost more than half those do not require technical ability or specialty. Okay? So kahit sino pwede. How? Just go to that site. Join that MozillaPage.org. You'll be notified depending on where you join. Iba-iba kasi may hawak na. So ako, I handle translation and localization. And yeah, some into coding. Okay? We also have the Mozilla Developer Network para doon sa mga IT, ISCS students. Okay? So pwede mong gawing reference yung Mozilla Developer Network. So the mission of MDN is to provide complete, accurate, and helpful documentation for everything about the open web. Pwede ka rin mag-contribute sa MDN. Pwede ka mag-edit. It's basically a wiki. Okay? So yung wiki na yan, pwede mong edit if you see some errors or kung ikaw nag-research, pwede siyang gawing reference. So if it is open technology, exposed to the web, Mozilla Developer Network wants to document it. Okay? So we have the MDN community, we have those lists, the Twitter, Google, okay? I'll send you the slide deck link later, okay, after the session. Okay? Announcement, okay? So if you need a place for you to work on your personal projects, if you want to conduct meetings for small groups, we are offering this space. So kaya lang, this is not open every day. So what you need to do is go to that site and book. Halimbawa, Tuesday next week or Wednesday next week, gusto niyo mag-meeting ng klase niyo, kaya ikaw mismo gusto mong research, instead of going to a cafe, yeah, we can offer the space. Pero you need to book kasi hindi araw-araw may tao dito. So we need to know kailan niya nag-book. We will open the space. Okay? It's free. We'll take care of your coffee and water and Wi-Fi and aircon. Medyo mainit lang talaga sa labas. Kaya the aircon is noisy now. Okay. There. This is our battle cry, and now we go to Rust. Okay. So this is the main topic for today. So enough yung kanina introduction into Mozilla. Now, sino yung nakatry na ng Rust before today? Narinig na yung Rust before today? Cool. Okay. Anong pagkakaintindi mo, sir, sa Rust? Walang database, okay? Yeah, what had you heard about Rust?
Yung structure niya pa, low level, pero dynamic.
In language. Cool, okay? So the structure niya is from low level, pero yung language is high level. Okay, awesome. Ako, I have heard of Rust personally more than 5 years ago. Okay? Narinig ko na siya, pero hindi ko pinapansin. Tapos lately, parang ang dami ko ng kaibigan in the local scene na asking, hey, kaya Mozilla, kaya kayo magkakaroon ng user group ng Rust sa Pilipinas? Parang sabi ko, may gumagamit ba ng Rust sa Pilipinas? True enough, meron. Okay? Meron. So me, myself, I'm trying to learn Rust. So what I'm going to show you is more of an introduction, and later, we have a video recording of an actual lecture at Stanford University of a Mozilla employee. So it is the best way to introduce Rust to most people. Ang unang requirement lang doon is at least kahit paano meron kang background sa programming. Okay? So ngayon pinagdidebatehan namin ng mga kaibigan ko is, ang Rust ba ay pwede mong gawing programming language ng isang tao na walang background sa programming? Ako, I believe pwede, pero medyo mahirap ituro. So now the premise is, Rust can be your second language, but the only premise is you should have prior knowledge and background to any programming language, okay? So Rust is a systems programming language that runs blazingly fast. It's so fast, okay? It prevents seg faults. Ano yung mga seg faults? Segmentation faults, okay? Guarantees thread safety. So, ano yung seg fault? Yung access violation, mga faults, okay? Yung stuff na ayaw natin ma-encounter sa Windows, okay? Pag nag-program ka, sometimes hindi mo iwasan yun, okay? Yung mga memory violations, and so on, okay? Sino nakagamit ng C++? Na-encounter niyo yung mga ganong error? Sir, hindi. At least once, na-encounter niyo yung mga ganong errors, okay? Now, what is the Why is Mozilla caring about Rust? Any idea? Why is Mozilla caring about Rust? Lalo sa mga unang may nakarinig. Ako, personally, I heard of it a few years back during sa isang Mozilla conference, pero wala pang demonstration that time. That was, I think, 2011. And then, a few years after that, I met a couple of guys from Google, employees ng Google, but they are based in Japan and Australia. Mga Pilipino. Maraming employee ng Google na Pinoy. Okay? So they're telling me that, hey, you guys at Mozilla, you're doing cool and great stuff with Rust that we are using them in-house. Okay? So some employees of Google, they use Rust. Though meron sila sarili ng programming language. Ano yung programming language ng Google? Go lang. Okay? So, Go language. So, but some people, they use Rust. Ano ba yung connection ng Mozilla sa Rust? Ang Rust ay ginawa ni Graydon Core. Si Graydon Core ay paid staff ng Mozilla. Hindi siya project ng Mozilla. Nagkataon lang si Graydon Core ay employee ng Mozilla. Bakit niya ginawa yung Rust? So, he is one of our engineers. Gusto niya na mapadali yung buhay niya. So, master niya yung C++. Gusto niya gumawa ng C++ na mas mabilis sa C++ na parang siyang JavaScript, lightweight, at pwede gamitin sa web. Okay? So, yun yung relevance nun. Starting 2009, ini-sponsoran ni Mozilla Research. Isang department namin, yung Rust na programming language. Okay? Para sa development. Remember, si Brendan Ike, dati naming CEO, siya yung naka-invento ng JavaScript. So, yung innovation is at the brains, at the heart of Mozilla. Okay? Ano ba ang features ng Rust? It has zero cost abstractions, moves semantics, it has guaranteed memory safety. Okay? You can do threads without data races, trait-based generics, pattern matching, type interference, minimal runtime, efficiency bindings. Bottom line, it is safe to use. Okay? So tama sabi niya, parang siyang low level na high level language. Medyo mahirap intindihin for beginners, but later on when you go and deepen yourself into software development, software engineering, you will understand that. Okay? Now, ano yung mga projects na gumagamit na ng Rust? Si Dropbox, they said a few weeks back that their file storage system is now using Logic Packet, which is basically built using Rust. Okay? So, sino yung gumagamit ng Dropbox? Ako, yung buhay ko. Okay? So, most of my files in my Mac are in the Dropbox. At least, masira na yung hard disk ko, nasa cloud siya. Next, this is an exciting development into Firefox. We have a new browser engine, it's called Servo. Okay? So, it's the new Mozilla Parallel Rendering Engine, okay? And it's developed in cooperation with Samsung. It uses Rust. So, sir, ano ibig sabihin yan? In the future, when you develop add-ons for Firefox, you should know Rust. Kasi yung mismong browser will be built using Rust. Okay? Sir, kailan namin matatry yung Servo? Maybe later this year. Okay? So it's still not in production, it's still engineering, not engineering release level. Okay? Si OpenDNS. Gumagamit pa kayo ng OpenDNS? Kung gusto nyo makita yung real-time site na refresh, hindi yung nakacache lang sa ISP nyo. So, you need to add. For the Rust, add. Collab na lang po. Thank you. Okay, so OpenDNS, it uses some of their components are built in Rust. And there is an operating system called Redux OS. Okay, so it's a microkernel OS being developed in Rust. Okay. So doon. Questions that I may not be able or may be able to answer. Okay. I'll send you an email after this session. It will contain the link to this presentation. To the group, we have a Facebook group, which we also are planning to have a group study, an online group study. We'll be using a Moodle server. Alam niyo ba yung Moodle server? Nakarinig na kayo nun? So it's an online learning environment, website siya, na ginagamit ng ibang schools para sa collaborative and online learning. So we are doing that. I'm talking to some of our colleagues, some other developers. They will be helping me build that course. It's free, but you'll have to enroll with your email. Okay, so it's a site. So all the links will be there. Now we go to the lecture of Aaron Tool. Okay, so this is a around 50-minute clip. Okay, so it's an entire lecture. Okay, so this was recorded at Stanford University. Okay, so nag-lecture siya. Kung gusto nyo kumuha ng kape, gusto nyo pumunta sa CR before I play the clip, you can do it now. Okay, ano ba? Gusto mag water break, CR break? Wala? Sure? Then I will play this. O sige, kuha na kayo before I start this. Yeah, libre yan. Sige, bukas may bayad na yan. Okay? Then we'll start. So this is a 15-minute clip. I think. Actually, yung mga hindi nagpakilala kanina, pag-resume natin. Kaya naman pala, the outside temperature is 35. Paglabas mo left side. Hindi ko masyadong form. Yung rest ko mga dito lang sa may likod itong wall mo. Paglabas mo left side. Yung Mozilla Research, it's a department within Mozilla. They're so small. I think they have less than 10 employees. Locally, ang employees ng Mozilla, less than 1,000 lang. Yung paid staff, we have 10,000 volunteers. We have less than 1,000 paid staff. And yung Mozilla Research is just a small department. Sa headquarters, maraming Pinoy. Meron kami mga student ambassadors sa perpetual ganyan. Sa UE, alam ko meron dati, hindi ko lang alam kung active pa sila. Sa PWU, I haven't heard of any student ambassador. Bago yung IT. Pero kasi pagka student ambassador ka, not necessarily IT course. So I don't know, pwede yan. Yun yung common misconception kasi na for you to join Mozilla, you need to be an IT or computer science.
Second. Third.
If you you have an organization, you have a meetup, you need a venue, pwede rin namin offer to. Basta walang conflict sa schedule. Yeah, we also host other meetups here, other organizations, like the Python Users Group, AngularJS Users Group. Next month, or I think June, you'll be hosting the WordPress Philippines Users Group. Okay. Marami pang ibang users group. PyLadies, mga Python ladies, mga Pythonista na babae. They do their meetups here. Basta wala lang conflict sa schedule ng space. We normally grant naman the best. Walang bayad. Just let us know siguro mga 2 weeks before. Huwag naman yung, sir, pwede pa akong mag-meet up next week. Ayun mga ganun. Okay. Just let us know in advance. Sir, pwede ba kami mag-meet up dito sa space? Manonood lang kami ng film? Oo, basta hindi pirated yung film. Pwede. Minsan may ganang org pa, sabi na, so can we have a film showing there? Yeah, for as long as the film that we're going to show is not a pirated clip. Pwede naman. Sino nagpo-program sa C? C++. Java, si Kevin. Java. PHP. Ano pa ba? HTML pa eh. Basic. Nakita niyo yung nag-post sa Facebook? Na-hack daw yung election machine. Pero yung code niya basic. Okay? So, I'll play this video now. Later on, kung may tanong kayo, I'll take down the questions. Kung hindi ko siya masagot, I will ask Aaron to give me the answer or email me back. Okay? So, pwede yun. Okay? Kailangan may hirap ka. Okay? So, this will run for around 50 minutes or so, and just relax. Gusto niyo bang patayin ko yung ilaw din sa harapan, or hindi? Patayin na lang yung sa harapan. Cool. Actually, side na yan pala. Here. So this was last year.
Yeah, so I'm Aaron. I'm an employee at Mozilla Research, and I'm really excited to tell you about our Rust project, which is been an ongoing research project for the last sort of 4 or 5 years in terms of having a lot of manpower behind it, and it's just on the cusp of actually being introduced in 1.0 sort of to the world to use as a more serious product. So my background is in programming languages. I did research in programming languages, and it's kind of an interesting time to be a person working in programming languages, because for a long time it had been considered a sort of dead area. Everybody was happy with C or Java or what have you, but in the last few years there's been this kind of resurgence of interest in new programming languages. Lots of different industry groups coming out with languages, including Facebook and of course Mozilla. So with all these languages coming out, you might ask, okay, what is sort of special about Rust? Why Rust? Why is Mozilla building Rust? So the kind of headline for Rust is safe systems programming. And I'm going to explain what I mean by that in the next few slides. But in terms of sort of the lineage going into Rust, you have traditional systems programming languages like C and C++, which I'm sure all of you are familiar with, and then languages that might be a little less familiar, like ML and Haskell. Actually, I'm curious, who in the room is familiar with either of those languages? Okay, so quite a few people, that's great. So Rust is sort of trying to blend the best of both of these languages to get at this problem of safe systems programming. What's that?
Avoiding the bugs?
Yes, exactly. Okay, so one question you might wonder is, why is Mozilla interested in creating a programming language? So you probably all of you know that Mozilla is the organization that created the Firefox web browser, which is currently written in C++. And it turns out actually that web browsers have a sort of need for a combination of things that are in deep tension. So on the one hand, web browsers need a high degree of control over the machine. They're sort of asked to do very complex tasks very quickly. They're asked to display media. They're asked to have all of these tabs running simultaneously, running code that's untrusted, that's been downloaded from the internet. And then on the other hand, they need safety because they're running this untrusted code from the internet, right? And everybody's out there trying to break into your machine. And these two are sort of at odds because languages like C and C++ that give you the kind of control you need to get the performance for a competitive browser also leave you open to all kinds of security vulnerabilities, right? So you're constantly hearing this, Firefox has been patched or Chrome has been patched. Somebody can break into your machine through a website. So the idea is we want to build the next generation web browser, which is a project called Servo, and we want to do it in a new language that tries to be better at giving you safety and control at the same time. And so Rust and Servo are kind of this symbiotic pair of research projects. Okay, so that's the really high-level picture. Now I want to spend a little bit of time going into more detail about exactly what I mean by control and what I mean by safety. So let's start with control. So C++ is sort of the best existing language in this respect. And even in just a small snippet of code, we can start to see the kind of control that you get over the machine. So for example, if we declare a vector in C++, we know exactly how that's going to be laid out in terms of the memory. So in particular, there are some fields of the vector, including a pointer to the actual data and some metadata about it, that all live on the stack. And it's very important that that data is allocated on the stack. And there's a pointer that goes directly to the heap. And in this particular case, we have a vector that's containing a string, and we sort of have the same pattern again, where the string is itself another vector, and the relevant pointer and metadata is stored in line in the array. So to actually get at a piece of string data, you follow these two indirections. One to get into the vector itself on the heap, and then one more to get into the string. And we'll contrast that with some other languages in a second. But the high-level point here is you know exactly what things are going to look like in memory, and you have a lot of control over that layout. In addition, C++ gives you various kinds of pointers, including things like these lightweight references, which can point into the heap and they can point into the stack. And there's no overhead for doing so. You have sort of all of the power you're normally used to with pointers. And then finally, there's something implicit here, which if you know C++ is sort of obvious. So at the end of this function, the vector goes out of scope. And as a result, it's disrupted from and its memory is free. You didn't have to say anything for that to happen, so that's a nice convenience. But on the other hand, you know exactly when it's going to happen by reasoning about the scope. So that's in contrast to something like garbage collection, where the data might be freed at some point in the future, but you don't know exactly when, you can't control it, it might be inconvenient. Okay. One of the principles that you get out of C++ is something often called zero-cost abstraction. And what this means is that you can build up libraries like vectors and strings that are reasonably convenient to use. They give you a nice abstraction, but when you compile it down, it's nothing different than something you could have written by hand in assembly. You're sort of not giving up any performance in doing this. Okay. Now, if you look at a language that is safe but doesn't give you control, like Java, the story is very different. So in Java, if we try to sort of set up the same scenario where we have a vector containing strings, we have layers and layers of indirections because Java enforces a kind of uniform representation on everything. It doesn't give you control over stack layout versus heap layout and so on and so forth. Right, and so in Java, any abstraction comes at a cost. And I want to be clear here, I've been focusing on memory layout as a relatively simple example, but this applies to many, many things. So being able to choose between static dispatch and dynamic dispatch. Again, in Java, basically everything is dynamically dispatched. Everything's going through objects. In C++, you have a choice. Template expansion is related to that. And there are many more examples. So what we want is to retain this notion of zero-cost abstractions and control from C++, but to somehow get the kind of safety that languages like Java, ML, Haskell, and so on provide. Okay, so now what do I mean by safety? So let's go back to this example in C++, where we've set up a vector, we have a pointer into that vector, and let's just say for the sake of argument, the vector has one element. If we then try to push an element onto the vector, well, it's out of capacity, so it's going to have to allocate a new chunk of memory and copy over the data, and at that point, it'll swing the data frame, right, to that new location. Problem is, we're left here with the existing reference, elem, to the old location on the frame, right, that hasn't been updated. So this is the classic dangling pointer problem. And of course, if you then go on to dereference that pointer, bad things can happen. People can break into your machine, right? This is the source of security aspects, like a very simple example. Okay. So I want to sort of take a closer look at exactly what went wrong here. What are the ingredients we need to create this kind of security problem? So basically, I want to say there are two things happening at the same time. One of them is aliasing. That is, we have two pointers to the same, or multiple pointers to the same memory location. Right, so we have the data pointer, which was being updated, and then this elem pointer, which sort of didn't know about the update that happened. So aliasing is one thing, and then mutation is the other. Right? If you weren't allowed to change the data, then this problem wouldn't happen. So it's this combination of having multiple pointers and being able to change the data under those pointers that can cause things to get out of sync, and then you can read unallocated memory. And by the way, please ask questions throughout. Are there any questions up to this point? Yeah.
What architectures right now have you implemented your language?
So the Rust uses LLVM as a backend. So basically, it supports all of the architectures that LLVM does. On the other hand, that's the in-principle answer. There's a lot of work to make different things like the standard library work on those architectures. But we work on x86 machines. We work on ARM, Power, and a few others. I mean, it's mostly major architectures at this point. Yeah.
So how much do you depend on the safety of LVM? LVM makes transformations on the abstract syntax tree. It eventually walks into code.
Yeah.
It produces various optimizations. It makes assumptions about the safety of those.
Right. So that's a really great question. One interesting thing about targeting LLVM is that we inherit a lot from C and C++ because that's sort of where LLVM is targeted. And as we'll see later in the talk, in C and C++ there's this notion of undefined behavior, something like dereferencing a pointer like this. And part of the idea of undefined behavior is it's a contract between you and the compiler. If you do something like this, the compiler is free to optimize it in crazy ways. I mean, basically you have no guarantees about the semantics of your program, right? On the other hand, if you don't have undefined behavior, everything is supposed to work out hunky-dory, right? And so part of the idea with Rust is that it gives you a lot of tools where basically if you follow the discipline I'll be showing you in Rust, and the compiler enforces that, then you never introduce undefined behavior, right? It's only if you sort of break out the rules. Right, so I'll spend about half of the talk talking about concurrency. Any other questions? All right. So one thing you might be wondering is, doesn't garbage collection solve certainly the safety problem? Well, as I sort of already mentioned, garbage collection gives up a lot of control. In particular, you lose that deterministic destruction where resources are free. And it also requires a runtime, which is a sort of substantial abstraction penalty that you're paying. But there's sort of a more interesting reason that garbage collection isn't the whole answer here, which is that garbage collection solves a certain category of problems, like memory safety problems, like the dangling pointer problem I showed you. But there are many other classes of bugs that garbage collection doesn't give you any help with, such as iterator invalidation, where you have a piece of code that's iterating over some data structure and makes a call that updates that data structure, therefore sort of invalidating the iterator. Right? Garbage collection is completely orthogonal to that. And there's also something called data races, which come up with concurrency, and I'll spend a while talking about that later. But I just want to say, garbage collection is, even if you're willing to give up some control, it still doesn't solve all the problems you might want to solve. But Rust will actually help you with all of these problems. Okay, so that's the problem space. Those are the goals. So what is Rust? So at heart, Rust is about ownership. There's a discipline built deep into the type system that enforces a notion of ownership and a sort of related notion of borrowing. So the idea is that every resource in a language always has an owner at all times. And by resource, I mean things like a vector, but I also mean things like a file or a log. It can mean a wide variety of things. Once you have some resource, you can lend it out on a sort of temporary basis. That's what we call borrowing. And when a resource is borrowed, then certain restrictions apply. So for example, it might not be mutable, or it certainly can't be freed until the owner actually says, I'm done with the object. Okay, that's ownership at a very high level. I'm going to be explaining this at sort of increasing levels of detail. That's the core solution. So sort of in graphical form, how does this help? Well, basically, it solves all of the problems that I've mentioned. You don't need a runtime to follow this discipline. It's totally done at compile time in the type system. So that puts you sort of in the ballpark of a language like C++, giving you the control that you wanted. You get memory safety, which is one of the benefits of garbage collection. But then you also get data race freedom, which there aren't really mainstream techniques that give you that kind of guarantee. And again, I'll come back and explain exactly what I mean by data race freedom, but it has to do with concurrency bugs. Okay, and then I just want to briefly say, I'm going to spend the rest of the talk basically focusing on this notion of ownership and borrowing, because that is really the heart of Rust. But the fact that Rust is as successful as it has been, sort of as an early project, has to do with a lot of other things as well. So Rust feels like a very modern language. It borrows a lot of ideas from languages like ML and Haskell that make it feel very nice to program in, despite the fact that you're sort of dealing at this low level of abstraction and exercising this kind of control. And then finally, I just have to give credit to the open source community around Rust. I introduced this slide both to give credit, but also to invite all of you to join this community. It's very open, very welcoming. If you're interested in this stuff, it's very easy to get involved in. Okay. So now let's actually dive into some of the details. So I'm going to start by talking about the core concept of ownership, which is very simple, and then we'll move on to borrowing. Okay, so at the stick figure level, imagine you have some resource like a book. So as I said, these resources always have a clear owner at all times. So right now we have an owner on the left. Ownership can be transferred to a different party, and at that point, the original owner is irrelevant. So you can think of owners here as threads, you can think of them as functions, pieces of code. But basically, ownership transfer makes the original owner irrelevant. And when the final owner says, I'm done with this resource, the resource is destroyed. In the same way that we saw the vector example before, the destructor is run. So it's only when the final owner just drops it on the floor that the destructor is run, just like it is in C++. That's it. Very, very simple discipline. So in terms of, remember we looked at this problem of memory unsafety and said you sort of need these two things, aliasing and mutation at the same time to cause this problem. So ownership chooses basically to forbid aliasing. There's always exactly one owner. There's basically only one alias that can be used at any time for an owned resource. But the owner can do anything they like to the object, so they can certainly. Okay. That's the stick figure version. Now let's see the same thing with some code. Oh, yeah, question.
ownership is a property that exists only for California.
Yes.
And so, is it true that there are not algorithms where ownership is mutable and usable at execution time? And then you actually have a representation for some data type of ownership.
Right. Again, great question that you sort of looking forward ahead to some stuff I'll cover later in the talk. So yes, I mean, so certainly this basic ownership discipline, before we get to borrowing, is way too restrictive to write many algorithms. It's actually surprising, it gets you surprisingly far for programming applications that just use libraries of existing data structures and so on. But if you wanted to implement a doubly linked list, you'd be in trouble with this approach, right? And that's a pretty core data structure. So I'm going to come back to this point. There are various ways to bend the rules, but it's all carefully impactful. Other questions before we move on? Okay, so I want to come back. Now this is an example. Now we're looking at Rust, but it's sort of similar to what we saw with C++ earlier. So we introduce a vector. It's laid out on the stack exactly as it was in C++. When we create the vector, it's owned by this piece of code on the left. So that owner can go ahead and mutate it. It can push elements onto the vector. That's totally fine. And then at some point, it can pass that vector to another function. And notice this function take is just writing the type vec directly. No sort of incantations or anything else. By default, if you just write a plain type, what you're saying is that when you pass me this argument, you are actually passing ownership of that document. Okay, so this borrowing stuff is something you will annotate, as we'll see later. But by default, if you don't say anything else, you're transferring ownership. And so that means after this function call to take, the original function give no longer has ownership of the vector. Basically, it's completely irrelevant. Okay, and in terms of what this actually looks like sort of at runtime, when you make the call, right, you're going to copy the stack data into the stack frame of take. And then at that point, the original stack data is still there, but it's sort of unusable. And the type system is going to enforce that, as we'll see in a second. Then take executes. And here's a key point. If take didn't pass ownership of the vector somewhere else, we're back into the same situation we saw with the original C++ code. At the end, it's going to free the vector. And so now you have what looks like a dangling pointer here, but it's grayed out. Okay, and I'll show you what that means at the compiler level. Okay. So you might worry, what's to prevent give now from going on and using this vector, which has been deallocated? So this is where the type system actually comes in and does some checking for you. The type system understands that you've transferred ownership of the vector after this call. And so if you then try to use the vector in any way, say by pushing more elements, you'll get a compiler. It says, this vector has been moved, you don't own it anymore, you don't have access to it. So even though there's a dangling pointer in the stack frame, it's not usable, so it's not causing any trouble. Right? That's kind of the point here. And eventually that stack frame will be popped. Okay, and this kind of checking certainly covers basic errors like use after free, as we just saw, or double moves where you're claiming to transfer ownership to multiple places. And we'll see some more examples of other things that it addresses later on. Any questions about just the basic ownership discipline? Yeah.
Do double type like int and everything also?
Good question. So there's a notion of what we would call copy types. So things, scalar values like integers are considered copy. And what that means is that when you do something like this function call, where it looks like you're moving ownership, you still retain access to the original value, because basically you're saying that you've just copied the value when passing it in some sense. And in particular, so the compiler checks whether copy is a valid thing to apply to a type, and you can't use it for types that involve the heap in any way. So it's always shallow scale types. But yeah, if you had to follow this discipline for just basic programming with integers, you'd be in trouble. Integers are not resources, right? They're just values that you can easily copy. Anything else? Okay. So now let's look at the other aspect of the ownership system, which is borrowing. Now there are two forms of borrowing in Rust, and we'll look at both of them in turn. So the first is what we call shared borrowing. And it's a little hard to imagine the right physical metaphor here. But it's as if the original owner is able to simultaneously give access to a resource to some shared group of other parties. And for that to solve the safety problems, of course, we've created aliasing, therefore we must rule out mutation while this is happening. Right? So you can share pointers to this thing with all of your friends, but none of them are allowed to actually mutate the data through your aliases. Okay. Then, in contrast, there's also a notion of mutable borrowing. And in this case, you're sort of lending it out to one party, who could, for example, subsequently lend it out to another party. But there's still only one borrower active at a time. Right? So here we're ruling out the aliasing but allowing mutation. And unlike the ownership transfer situation I described before, the original owner is sort of still important here. There's a stack discipline, basically, where ownership is getting returned from party to party until it goes back to the original owner. Right, and as I said, this approach prevents aliasing and allows mutation. Okay, so that's the stick figure version. Here's the code version. I'll start with shared borrowing. Okay, so the code on the left is pretty similar to what we saw before. Really, the only difference is that there's now this ampersand in front of the vec, and the code on the right has an ampersand in front of it. Right, and that, as we saw in the previous slide, that designates a shared borrow. Right, so initially the code on the left owns the vector. It can mutate the vector, pushing some content, and then it hands out a borrow of the vector to the code on the right, or a shared reference. What this looks like at runtime is a little different than what we saw before, because these references are just pointers. Right, so this is also referencing the sort of C++ things. Okay, and then the function on the right can do whatever it does, but unlike the case we saw before, when it finishes, right, it's relinquishing ownership not of the vector, but of the borrower. It's saying basically the loan has expired. And so that pops the reference off the stack, but the original vector is still available. And that means that the original code could go on to mutate it or transfer ownership or do whatever else. Now remember, I said for this to actually solve the safety problems, you can't allow mutation while this is going on. So there are certain things you won't be allowed to write in the function, in the use function. Right? You can't push things onto the vector. You can't mutate the contents of the vector. Basically, it's a frozen object from your perspective. You can read from it, but you cannot modify it in any way. And that's all, again, enforced and compiled upon by Rust's type system. Okay, and I'll put an asterisk here because, as I said, you can bend the rules in various ways. We'll see that a little bit more later. So that was shared references, shared borrowing. Here's an example of mutable references. So this is a function that's just pushing all the contents of one vector onto another. So the source vector is taken as an immutable borrow because it doesn't need to be updated, and the target vector is taken as a mutable borrow. And then internally, you are allowed, to call mutable methods like push on the target vector because it's a mutable borrow. And I'm going to skip the details here, but basically, although you're writing this for loop at what seems like a high level using these iterators and so on, it compiles down to the same kind of code that C++ uses. So there's some zero cost abstraction going on, but that's not super important. Right. So in terms of what's going on in the layout, as you're iterating over this vector, you're getting references onto the heap in the form of this elem, and then you're pushing copies of those references over onto the other vector. Okay, now here's an interesting question. One thing that can go wrong with this kind of code is if you happen to pass the same vector as source and destination. Right? Let's stop here and see exactly what happens. So suppose we've started the loop, right? We have an elem pointer like this, and the next thing we're going to do is push that onto the vector. But now we have the same kind of problem we had before. If the vector is out of capacity, that's going to involve allocating assembly memory and copying over the contents. And now we have a dangling pointer again, right? And so if we continue iterating, we're going to try to read a dangling pointer, we're going to have the same kind of safety violation. They are by value, but these, a parameter like this is taking a reference, right? So it's a little hard to answer that question, I guess. So you can think of it as by value, but then you have reference types, right? Yeah. Okay, so it would be bad if Rust allowed this, but it doesn't. So how is this ruled out? Well, we have this function signature, right, that says it's taking, on the one hand, a shared borrow of a vector, and on the other hand, a mutable borrow of a vector, right? And then at the call site, we're taking this borrow, right? Ampersand you can think of as a sort of request alone, right? Request to borrow this value. And the problem is that we can't have both of these borrows simultaneously. So Rust is actually tracking which values have been borrowed in what way. And it can see that you're trying to borrow the same vector as a shared borrow and a mutable borrow, which would introduce aliasing limitation. And so you get an error. That's ruled out. So this is another kind of bug that Rust can catch pretty well. Another way of thinking about this is that when you have your hands on an ampersand mute value, that is the only active alias of the underlying memory. That's the only way to do anything. Just to spell this out a little more graphically, in an example like this, when we write ampersand vec in that let elem line, that introduces a borrow that lasts for the whole scope. So if we try to push later on in that scope, we get the same kind of error we got before, but in the previous example. That vector is borrowed, you can't mutate it, right? But once the scope ends, the loan is complete, and then you can go on and push it. Right, so there's this kind of stack discipline for borrowing, and this fine-grained tracking of which values have been borrowed that lets Rust catch these kinds of bugs. Okay. So that's the end of the basic ownership and borrowing story. I'm going to talk about concurrency next, but before I switch topics, I just want to make sure this part was clear. Yeah?
So how they can do optimizations around the borrow, non-mutable borrow, I should say, knowing that they can't be changed. So it might actually improve the code and not find that.
Absolutely, and that's something we're not taking as much advantage of right now as we could, because we just use the LLVM toolchain and it doesn't know this stuff. So we can communicate some of it, but I think there's a lot of avenue for actually getting faster than C++ this way, because you know so much more. Right. Any other questions, comments? Okay, so now I want to switch gears and talk about concurrency, which is another enormous source of bugs that a lot of recent languages are targeting in various ways. And this is, I'm going to sort of go through a litany of different kinds of approaches to concurrency in the way that you can model them in Rust and how they help you catch bugs. So let me start with one particularly pernicious bug that comes up in concurrency, which is the notion of a data race. So a data race is defined as having two threads that are accessing a piece of memory where at least one of the threads is doing write, and those accesses are not synchronized in some way. What synchronized means here is actually quite flexible. There are just simple reads and writes where you just say to the compiler, this is considered synchronized, and that has certain implications about optimizations. So I don't necessarily mean locks or something like that. It could be much lower level. But this goes back to what I mentioned before. If you have a database in a C or C++ program, the compiler can do anything. Basically, your program has no meaning if you have this kind of bug. Because the optimizer can sort of break your code arbitrarily. But this kind of bug is very, very, very easy to create by accident. Right? And it can, because of that undefined behavior aspect, basically this is as problematic for safety as the dangling pointer problems that we were seeing before. So if you want a safe language, you just can't allow databases to run. So the ingredients of databases basically come down to aliasing, because you have to have a few threads, mutation, because at least one has to be writing, and then no ordering, which is another way of saying lack of synchronization. And of course, those first two bullets are familiar from what we've seen so far with the ownership and borrowing. So you might expect that we could sort of reuse some of the tools that we've seen already, and that turns out actually to be the case. Right, so I sort of mentioned that there are a lot of languages trying to tackle concurrency bugs in various ways, and many of them propose specific models of concurrency. So there's the actor model, which is espoused by languages like Erlang, for example. And there, in principle, you're forbidding aliasing, so you're passing around own values between different actors. And on the other hand, there are functional languages like Haskell, which let you alias all you want, but disallow mutation. And Rust's approach is sort of all of the above, in the sense that you can do either of these. You can, as we saw, with different kinds of references, you could allow or disallow mutation or aliasing, and do so at different times. Okay, so that leads to sort of many different concurrency models that you can build up in Rust. And all of this is done in Rust libraries. It's not built into the language in any way. Okay, so let me start with a really simple discipline, which is basically the actor model. Yeah?
Mr.
Because, why is it not built into the language? So I actually take it
Because the implementation takes all of the concurrency from a very low level of the machine and pushes it up to a level or two so that you can do things underneath between Rust and the machine to accomplish magic.
Right.
Doesn't seem to be the right thing.
So it's pretty interesting. When Rust started, it was taking a very different approach where concurrency was baked very deeply into the language, and it sort of followed the actor model. But over time, what we realized was that these kinds of disciplines of concurrency actually just fall out of the ownership system. And I'm going to show you what that looks like. But basically, you can build in a library something that gives you the guarantees you want. But by making it a library and rather than the language, it's open-ended. Anyone can build new libraries. You can keep adding new concurrency constructs without actually changing the whole language. Right? So I think it's actually a huge benefit.
Yeah, they were asking the question about Mr. Passing the life. This is time to press slide. But Mr. Acker is a speaker otherwise, so he's not throwing snowballs at me.
Okay, good, I'm safe. Cool. Okay, well, I mean, one of the things I want to say is that Rust can do the actor model very nicely in the following way. So now I'm going to sort of go back to stick figures for a moment and think about these stick figures, instead of being different functions that are calling each other, different threads that will communicate. Right? And so in the actor model, a thread has ownership of some data, and that becomes a message that's passed to another thread. And that message passing is supposed to designate ownership transfer. Right? And then that other thread might form some other message and transfer ownership back over. And the key thing is that because it's ownership, there can't be aliases, so all communication between threads has to go through this message passing. Okay, so going from stick figures to code, here's what this actually looks like in Rust. Now I'll go through this fairly quickly, but so we first of all set up a channel, and a channel has two ends, a transmission end and a receive end in Rust, at least in the particular library we offer. And that looks like sort of this diagram in terms of the memory layout. So those two ends are sitting there on the stack, and then they point to some data on the heap. The actual data is not so important. Then we spawn some child thread. And this double pipe syntax, don't worry about it too much. It basically expands out to, we have some piece of code. We're writing a function, just an anonymous function, that is going to be the body of the child thread we want to run. Okay. And notice that in that child thread, we're mentioning the transmission side. Right? And there's also this funny keyword move going on. Right? So there's a lot going on here, but the point is, by writing move and mentioning the transmission side, we're saying this child thread is going to take ownership of the transmission side of the channel. Okay, so after this spawn, the parent thread is not going to be allowed to use TX anymore, just as if it had been passed in a function. Okay, and then when the child thread executes, it allocates a new vector. It does some stuff with that vector, maybe pushes some data into it, and then at some point it sends that vector back across the channel. Now this send only involves the stack data, basically. Just like every other ownership transfer we've seen, which is fairly small, right? That's just a few words of data that's being transferred from one thread to the other. The bulk of the data, which is sitting in the heap, didn't move at all, right? And that way you're passing pointers back and forth between threads, but you're getting a lot of help from the language to make sure that nothing goes wrong in terms of dangling pointers or aliasing communication that they're showing. But this is all just using the existing ownership discipline. Not even any borrowing, it's just pure ownership to transfer these between threads. Is that fairly clear?
It seems to me that there are two issues. On the one hand, you have the physical representation, the data structure. Mm-hmm. On the other hand, you have the abstract information which may be passed along or copied or moved or mutated and then put back into a data structure.
Yes.
And does the language differentiate strongly between that? Or is it basically really talking about the representation of the data in memory and deals more with the physical layout of that data and its sequences?
Right, okay. Yeah, so basically, okay, so the question is essentially, there's potentially a distinction between ownership transfer in some abstract sense and the actual physical layout that's involved, and how does that look to the language? So by default, the language unifies the two, essentially. Like when you write a data type, there's a sort of, you're assuming everything in it is owned. And so if you pass it along, you're passing that stack representation. But there are various ways to say to the language that you want some more abstract notion of ownership. And when you do that, that generally involves breaking out of the ownership system in some way, the escape hash bit at the end. But so you have the flexibility to do that, and that's very yes, there is. Yes, and that's also built up as a library. Okay. Here's another example of concurrency. So we saw the actor model. Here we're seeing this sort of pure functional model where we're just passing some data to a bunch of threads so that they can read from it. Right? This is a really simple model for concurrency. And in this case, the thing is, we have a bunch of threads that all have access to a vector, and it may not be clear at what point they're done with the vector in some sense, right? There may not be any single thread that clearly owns the vector or is going to outlive the rest. And so there's this notion of ARC, which stands for Atomic Reference Count, which is a smart pointer if you know C++. So it's a kind of pointer that does some interesting stuff when you work with it. And basically it's just maintaining a reference count, how many threads are actively looking at this object. And when the last thread destroys its ARC, basically, then the vector itself is destroyed. So in some sense, the ARC itself owns the vector. That's one way of thinking about this. But then again, you can reason about the layout. Inside the ARC, you have the vector just laid out directly, exactly as we saw before. And because that is stored inside the ARC, there are no aliases to the vector itself. Everything has to go to the ARC. In particular, the ARC only allows you to get out a shared reference to the vector, as you'd expect. The whole point is to allow aliasing between different threads. Okay, so that's pretty simple. There's kind of an interesting aspect to this though. So going back for a second to send, like we might use with the channel, the library is set up so that when you're sending a type, that type has to be marked send. What does send mean? Basically, it means thread safe. Okay, in particular, there are two forms of reference counting that are commonly used in practice. There's the atomic reference counting, which uses synchronized accesses to change the reference count. And then there's sort of non-atomic reference counting, which is much faster, but it's not safe for use concurrently. So the key thing is that those two types are marked send and not send respectively, and therefore you know if you're using the non-atomic version, there's no chance that it will ever migrate to another thread and create a thread safety problem. So Rust is actually checking that when you pass data between threads, that data is actually thread safe to use, right? And that was another class of concurrency bugs. Okay. Let's look at a few other concurrency models. So, of course, we have to talk about locks. Rust can do locks, and it has. So with locks, right? Normally you just have some type of mutex that represents a lock, and you have the ability to acquire the lock or release it at some point. But in Rust, the mutex type actually takes another type as an argument, and that other type represents the data that the lock protects. And so what's kind of interesting about this is the mutex never gives you direct ownership or access to that data. Instead, it gives you a kind of what's known as a guard in C++. So it's a value that points to the data, but doesn't give you full ownership. And this is a bit subtle, but you'll notice that in this function call, I have a lock, and I don't say unlock, which might seem strange. But actually, what's going on is that the guard that I get back when I ask for a lock will do the unlock when it's destroyed. So I get back this value, this value data. I can use data to mutate or otherwise access the data protected by the lock. And in fact, that's the only way I have of getting to that data. And the only way I have of releasing the lock is by destroying my guard data. Okay? And so if you put this all together, what this means is there's no way to access data that's supposed to be protected by the lock when you don't own the lock, right? When you're not actually in a critical section. Ruling out yet another classic class of concurrency bugs. Okay. That's maybe a little subtle to see, but hopefully the gist is clear. Yeah.
So you wrote in the text some data being flashed into Mozilla?
Yes, and that's right. So this is a place where the rules are being bent slightly, because obviously locking the mutex does involve mutation under the hood. But you don't want to require a mutable guard over the mutex, because then only one thread could own the mutex, right? The whole point of the mutex is to allow aliasing across threads. So actually what's going on here is very interesting, because, you know, like I just said, part of the reason to have a mutex at all is that you want lots of aliases to some data, and for those aliases to be usable for mutation, which sounds like a problem from what I've been telling you. But the other aspect of the mutex is mutual exclusion. So a mutex is ensuring at runtime that you never have multiple threads mutating at the same time, right? And so the overall discipline is still followed. It's just being performed sort of dynamically through the synchronization of the mutex rather than completely at compile time. Okay, but that's, again, just built up as a library. Does that make sense? There's a lot going on here, so it's helpful to me.
So you're using mutex to protect the lock, but that's a synchronization mechanism that allows you to run simple language.
Absolutely. And because this is all built as a library, it's sort of completely open-ended what synchronization mechanisms you build. But we have lock-free data structures, for example, and many other forms of more sophisticated, like barriers, semaphores, all kinds of stuff. Okay. Now I want to give one last example, switching gears from focusing on concurrency and concurrency bugs to parallelism, which is closely related but not exactly the same thing. All right, so a classic example of an algorithm you might want to parallelize is something like quicksort, right? A divide and conquer style algorithm. So here's sequential quicksort written in Rust, where we're given access to what's called a slice. So I guess I haven't introduced this notation at the top where it says vec and has these bars, but basically, or the square brackets. You can think of that as a sort of fixed size window into a vector. So it's not the whole vector, it's just a window into it. And that's kind of key for what's going on here. Because in particular, right, we start with this whole slice, and then we're going to pick a pivot point, and then once we've done that, we're going to actually partition the slice into two independent slices. And there's a function in the library called split at mute. What that's doing is it's saying you have a reference to some whole slice of a vector, a mutable reference, and you want to turn it into two mutable references to disjoint subslices. Right? And so that's safe, even though they're both talking about the same underlying vector. Because they're disjoint, you can't actually get into any trouble by using these to mutate the underlying data. Okay? And then we go on to actually do the sort. So that was the sequential version. We can do the same thing in the parallel version. Basically, the code looks almost exactly the same. So we do the partitioning, we get these two subslices. Only this time, we're actually sort of asking to do the recursive calls on some child threads, right, using this parallel join. Now, something very interesting is going on here because we have the parent thread, the initial call to parallel qsort, and we have two children threads, which are actually being given pointers onto the parent thread stack, which is a very dangerous thing to do, because those pointers must not outlive that stack thread, or you're going to be in real trouble. This is yet another kind of bug that is very easy to make in C++. The key point is, Rust only lets you do this if you're doing something like a join, right? And the type system can actually talk about whether you are accessing stack data or not. And in order to give out stack data to children threads, you have to be joining on those threads. And that's important because it prevents that stack frame from being popped while the children threads are running. Right? You're waiting for the children threads to finish before you continue and pop with them. Yes?
That's a global check of parallel.
Sorry, which check do you mean about the stack?
That if you split, you must collect.
Yes. So what happens is when all data in Rust has something called a lifetime associated with it, which I haven't talked about at all here, but it's sort of implicit. And that lifetime refers to the borrows that are active in that data. And there's a way of saying that the lifetime has to be static, which means there are no borrows inside. And that's a way of ruling out stack data, basically, or sort of pointers onto stack data. So in the libraries, what I'm saying is that there's one way to spawn a thread, just the spawn keyword or the spawn function that I showed you. That requires that the child thread have a static lifetime. Basically, you're saying the data that's being passed cannot have any borrows into the stack. But then this join function can take any lifetime. So basically, the type system allows you to say whether stack data is allowed or not. And then the libraries themselves build different APIs where they're tying this together with things like join. Does that help?
Not quite, but because there's nothing out there that implies it has to be static, unless it's a requirement split in.
So in this case, it doesn't have to be static, right? That's the point, because the join function is allowed to take non-static closures as an argument. Precisely because you know that the semantics is it will join those two threads at the end, so the stack frame will be valid for their entire duration. But the spawn function that we saw before, that has a static constraint. And so if you tried to do this with spawn, you'd get a compiler error. But if I just said spawn twice for the two children, that would not compile.
So the question is, how does join and spawn get the information that some portion of the data structure is that?
So they get it by, so I haven't shown you their type signature, so I'm sort of like alluding to this thing that I don't have on a slide, unfortunately. But basically, if you were to put their type signatures side by side, spawn actually says static in part of its type for closure, and join does not. And then, so then you're sort of hooking into the compiler, so the compiler knows whether stack data is involved or not, and this gives you a way to ask for it.
The language and not into the...
That's right. That's right. So the notion of lifetimes and static, that's a language feature. This is an example of the libraries taking advantage of it. Okay, I guess I should probably move on just to wrap up on time here. Sort of walk through there. So, okay, at this point I'm basically going to just conclude the talk. So, I've shown you several different models of, typical models of concurrency, how you can support them in Rust, and the kind of strong guarantees that you get that rule out classic bugs for each kind of model. But as I said, because this is all being done with the libraries, it's very open-ended, and it's under very active development. So, futures or promises are one thing. We have some, small support for it, but we want to do a lot more. And I mean, this is just an endless list. But one key point is that all of these sort of approaches to concurrency, and when you're building in Rust, are data erase free by construction. Okay, and now I sort of pull back the curtain, right? So I've been sort of alluding to this all throughout the talk, that the discipline can be too strict. You need to bend the rules in certain ways, right? Which should make you uncomfortable. Certainly makes me uncomfortable. So one of the key things that makes Rust work, or sort of workable, is the notion of unsafe code. So there's a keyword in Rust called unsafe, and basically within an unsafe block, you are allowed to break certain rules that are normally in play. Which may sound like you're just throwing all of these great guarantees that I mentioned out the window, right? And that's the typical first response. Like, if you have this, what's the point? And from a sort of purely theoretical point of view, that's totally true. As soon as you have one unsafe, there are no guarantees. But the key is, in practice, you actually need unsafe relatively rarely, usually in data structure libraries or like concurrency libraries. And you can use it in a constrained way. And in particular, you can hide uses of it behind an abstraction boundary, so that you can say, if you build a mutex, for example, under the hood, that uses unsafe, that breaks the rules in certain ways. But it guarantees at the public API level, the things you can actually do with the mutex are perfectly safe. And in fact, every use of unsafe has to make that guarantee. It has to be hidden behind a boundary so that users of that library get all the guarantees of Rust back. So it's encapsulation safe. So that is proved on the side, right? So this is not something that the compiler, at least today, can give you help with, right? But you can search for uses of unsafe in the code, right? You can find the places where you might be breaking the rules, and there's a strong sort of culture in Rust and its ecosystem to avoid unsafe whenever possible, right? So it's much easier to audit your code, and actually there is ongoing work in academia to try to go push this further and actually understand what it would take to prove unsafe abstractions safe, right? And maybe build some additional tools to help you do that.
Potentially. Yeah.
And that's exactly it. Like, and yet, at the end of the day, if this is going to work, it has to be practical, and you can't have a completely rigid set of rules like the ones I showed you and scale all the way up to a web browser. But our experience so far says you can get a really long way using unsafe quite minimally.
You really only need one unsafe.
Yeah, that's right.
It's pretty overly safe population.
That's absolutely
total outer break.
Yeah, exactly. So, okay, and then just sort of information about where Rust is right now. So we are deeply in the midst of a sort of final push toward a 1.0 release. So at the end of this month, we'll put out a beta, and then 6 weeks later, we'll put out the actual 1.0 final. And one of the things, up to this point, we've been breaking code on a daily basis. So it's been very hard for people to use Rust in a production way. But that's going to change with 1.0. So this is the point where it switches from research project to something real that people can build on. Obviously, I'm very excited about that. Great. Well, I think I'll just leave these conclusions up here and take any final questions. We do. You should download it and try it out. So it's fault very rarely. Yeah. So we have servo runs. You can browse the Rust GitHub repository on Servo. You can actually do quite a bit. It runs on phones, and in fact, this year, one of our goals is to have a component, a module of code that's shared between the Servo browser and also Firefox. So we're sort of trying all avenues for getting Rust actually in use in the organization. And once we're shipping one module, then they're stuck with it. Then Mozilla has to deal with Rust forever. That's our secret hope. Yeah.
What do you think is the biggest challenge with control? What keeps you up on it?
Oh man, what doesn't? That's a really interesting question. I worry that, well, you said besides the unsafe, but whether this vision about unsafe being constrained enough will actually succeed is one thing that keeps me up at night. And the fact that right now, to program even a simple data structure like a double related list that involves aliasing mutation requires a little bit of unsafe code. That worries me, but I think we have a lot of ideas for how to push the boundary further to give you building blocks that are safe that you can use to build things like linked lists. But I don't know. I mean, we're sort of doing the best we can to, make all these promises. Like I said, we're not going to break any code after 1.0. And so the other thing that keeps me awake at night is like, what if we made some of those decisions wrong and we haven't had enough time for feedback? Yes. Yes. Indeed.
What's your comment?
That's an interesting question. There aren't a lot of languages that are targeting this combination of safety and control. In a way, I think we're the only game in town there. Certainly, most other languages that are trying to do that level of control at least require a garbage collector. But I think Rust is often compared to Go, in part because Go is also by a company that makes a web browser and it's a decent language. People are sort of looking for a new thing. I think Go and Rust are targeting pretty different niches, honestly. So I mean, C++, actually, if I was to be honest, I think C++ is the biggest competitor to Rust. And part of the reason I say that is Rust, well, C++ has come a really long way, and a lot of the ownership stuff I'm showing you in Rust resembles what it's like to write C++ code these days. It's just that C++ doesn't actually check it for you, and a lot of it is done at runtime, right? And there's a lot of cruft in C++. It's an old language, right? But I think that's the biggest risk, is that C++ might get good enough that Rust just never has a chance to take off.
What's going to happen when the programming model changes and some of the stuff that's being experimented with, where they already referencing MNU up into the low level code, and to try to do access these sort of, how's that going to
So that's an interesting question. I think that there are sort of two answers to that. One is a theoretical answer and one is a practical answer. So in theory, the core discipline of ownership and borrowing, I think, is very widely applicable to many different architectures and styles of programming. So I think, even if, cache coherence goes out the window, for example, I think that ownership will still be an important aspect of programming and something that the type system can offer. On the other hand, practically we're very tied to LLVM right now. And who knows how long that will last. And hopefully someday there will be a Rust standard in many Rust implementations. That's a long way off.
I don't think you said so, but I'm assuming that in Rust you can manipulate pointers in the sense of
It's not the pointers I showed you. There is a kind of unsafe pointer that you can only manipulate in unsafe code. But that's used very rarely.
and unsafe only.
Exactly. Yeah.
The name. Lots of
Look it up online.
So if you thought about running an OS on this?
People have. Hobbyists have. Nothing too serious. But that's definitely something you could imagine doing. There's a lot of work needed to, right now, like Rust works relatively smoothly because you can assume an allocator, and the libraries are sort of shaped around that. And for an OS, things are a little bit different. So I think the standard library would have to change quite a bit to write a serious OS. But there are lots of hobby projects that are already. So it's very easy to link it to C libraries, and that actually drove a lot of the recent design. So that, in comparison to Go, for example, is much easier. Rust just looks like C. C++, the story's not as good, except that C and C++ are relatively easy to interface together, so you at least have that starting point. But Rust doesn't have anything like classes right now. It has other features that give you parts of what classes do. So that's sort of a little all over time.
It's essentially social coding. It's actually an explanation why it's a limiting damage. I have to go back to my grandfather. He used to borrow tools. Okay, it's very strict rule. Whenever you trim your tool, you bring it back in the same state or better. No damage. And having said that, it's his right, courtesy. When I came, born in Switzerland. When I came to the US, this young lady, professor in mechanical engineering, I was thinking about designing bikes. And I said, please, the first solution, well, you get these old bikes and you have to return it at the end of the court in a better state. Bingo. Unfortunately, she didn't look to that. That's not what made it work. Yeah, it's a social thing. I accept it the way I grew up. She sort of thought it was cute. And she abandoned it. And yeah, that's what you do for it. 5 cents is taught on safe. If you borrow nicely,
Right.
then you would have a problem.
Right.
So anyway,
Yeah.
I just shocked in some sense. That's why I asked probably questions to you, because I knew where I wanted to go. And to give the answers. Oh, yes, you did it. That's all. So I'm glad you discovered it.
Thank you all.
Okay. There. Isip pa ba kayo? Okay, pwede pa. Sinong nagpo-program na sa C before? Had used C++? C? Walang C? Oh, C. Okay. So, how do you see the relevance and how Rust is relatively C enhanced? Something like that, to that effect, okay? So, now we're going to a Q&A, except that I have to make a disclaimer. I'm not an expert in Rust. I'm trying to learn Rust. So if you have questions, I will take them, I'll take notes, and I'll ask the Mozilla HQ guys to give me feedback as soon as possible and for them to answer. Because after this session, as mentioned earlier, para sa mga latecomers, is that we are going to have a study group dealing with Rust. So we will learn Rust together with the help of people from Mozilla HQ. As of now, kasi if you will be searching, how are you going to learn Rust on your own? It's rather hard. the best documentation that we have for Rust is the documentation in the Rust website currently. Okay? But some articles are being fed into the Mozilla Developer Network, but they are not on a parang level 1 of knowledge. Okay? So medyo parang pang intermediate sa advanced siya. So what we are trying to do here is set up a group of people who learn Rust, because as mentioned by Aaron, it is the future. Firefox in the future will be built entirely using Rust. So if you want to develop add-ons, programs that will run within Firefox, Rust is the way. As kung kanina medyo nabuti niyo yung video, we have Firefox OS, it's our mobile operating system. Panasonic televisions, the latest smart TVs, they run on that operating system. And for you to be able to develop apps in it, aside from HTML5, you will need to use Rust. Okay? So yun. So do you have any question in mind as of this moment about Rust? Any suggestion? Because relatively, Rust being a public project, it's new to everyone. Even us here in the Philippines is relatively new. Okay? We had just the direction that we are going full blast with Rust as early as January this year. Okay? That's why we want the sentiments, we want the ideas of people who are interested in Rust. Right now, wala pa. So talagang either terminal, the Rust, what do you call this? The Rust compiler, yun pa lang ang meron. Though, it's also text-based, so from within Firefox, if you know Firefox Developer, you use Firefox Developer. So there is a version of Firefox, it's called Firefox Developer. So normally, ang available lang kasi is when you go to firefox.com, it will give you either Firefox Beta or Firefox Stable. So meron pang dalawang flavors of Firefox, yung Firefox 90, which is not that stable, and Firefox Developer. So you can download Firefox Developer. It's basically the same Firefox except that yung logo niya, blue. Kulay blue. Kasi kanya-kanyang kulay yun eh. So si Firefox, this is the stable. Si Firefox Beta, yung merong strip nakalagay Beta. Si Firefox 90, yung black. Si Firefox Developer, yung kulay blue. So you can download Firefox Developer. Anong kaibahan nga sa Firefox release stable? Pre-built na yung mga developer tools. Yeah. So anything that you need to develop web apps, and there's a built-in JavaScript and Scratchpad there, you don't need to go out. Okay, so that's one tool that you can use. Pero for compiling, terminal pa rin, or prompt ang ginagamit. So it has a separate. I think they are exclusive development for an integrated development environment. Pero let's see, it's still an ongoing experiment. So that's one. I'll think naman. Yeah. Sino ba? May tanong? Ano ang magiging use ng Rust? If you're thinking for Rust to be something like more of a front-end development language, medyo hindi siya ganun right now. Okay? So kasi some people might think that it is like what the normal programming language taught in school is. Okay? So that's why kanina sabi ko, katuwa namin is, it's like, you know, C language, and then you have any other visual programming language, it's in the middle. Okay? So parang sabi nga ni Aaron, the beauty of C, okay, and the power of other languages. So ganun siya. Okay? The uniqueness of Rust is that, if you have noticed, yung unsafe. When most programming languages promise that they are the most safe, si Rust, there's another realm niya na, okay, we'll allow you to break the rules and create whatever you like for as long as you define it as unsafe. Okay. Maybe on the next meetup, we'll have a hands-on activity workshop. Pati pag-install ng Rust, pero depende sa machine. Tapos, we'll try si Kevin, na-run niya na yung, na-run niya na yung latest code ng servo, pero it's not that fast yet. Pero just it will give you an idea ano ba yung magiging future ng Firefox. And supposedly, it will be out before the end of this year. Questions ba? Anything about Mozilla? If it is not about Rust? So, I'll send you an email. Make sure na tama yung email ninyo. Lahat ba nasa Eventbrite? Sino mo hindi nag-Eventbrite? Lahat Eventbrite? Okay, so yeah, I'll send the link there. It will give you the link to the Facebook group, to the slide deck, and to the video. And you'll be included in the invitations for the future Rust meetups. Okay? I just like to know, how do you feel about the time? If it's not this hot. It's really hot. It's 35 degrees outside. Okay? So, I checked the temperature. So, how do you find the time? Okay lang ba? O gusto niyo mas maaga? Sino mas gusto ng umaga? Gabi? Umaga? Umaga ng Saturday o weekday? Saturday, umaga. Gano'ng kaaga? 9 a.m.? 7. 7? How about weeknights? Weeknights. For the students. Weeknights will do? No? Okay. Morning on weekdays? On weekends. Weekends, okay. So who prefers morning on weekends? Saturday morning. Patingin lang para we have an idea. Sino yung Saturday afternoon? They prefer Saturday afternoon. May iba ayaw. Okay, sige. I think, yeah. Kasi the first session that we had, it's a Saturday morning. The turnout is not that good. So we thought of having it on a Saturday afternoon. Turnout is good. Yeah, parang we will just play by the year for the schedule. Okay? Questions ba? About Mozilla in general, FSA, Rust, Firefox, Firefox OS. Anything? Right now, wala pa, pero you can go to Mozilla-community.space. Okay, that's the site, Mozilla-community.space. I'll include that in the email. It will direct you to the community Rocket chat. Yeah, it's similar to Slack. Okay, so there's a dedicated channel for Rust there. Okay, sige ba? So we have Facebook, we have Rocket Chat. We will be launching this week the Moodle server for the learning environment on how to go with Rust. So, libre yun. So, you have to sign up. Ano pa meron? This month, we'll be announcing a series of another meetups related to different technologies. Tapos, starting Tuesday and every Tuesday of May, we'll be having webmaker kids here. So, may mga bata dito. So, kaya, pag itong lahat ng Tuesdays for May, the space is not available for co-working. So, if you want to work on your projects, the thing is you need to go to the Mozilla Community Space website. There, okay? So, if you need a place to work on, so, ayaw mong pumasok sa Starbucks, kailangan mo lang internet, tahimik na lugar, okay? The aircon will be fixed daw this week. Okay? Medyo talagang naghihingalo yung aircon pag mainit. Pero yeah. Okay? Wait lang. Sino pa? Tanong. Tanong kayo ngayon. Wala? Sure? Okay? So, before we leave group photo, so, dito na lang Kim. Dito na. Okay, so, that's all the group photo. So, lahat ng pictures na taken today by Kim will be uploaded to our Flickr site. When? I don't know with this guy. Okay, soon. Lagyan na ng watermark. So, lahat ng photos namin, public, nasa Flickr page namin. Flickr, username is MozPH. Okay? So, after the group photo, wala kang tanong.